Assalamualaikum warahmatullahi wabarakatuh. My name is Yustivan Ravanda Putra from from Electrical Engineering 3E. I will explain about electrical instrumentation of hydropower plant. Hydropower plant. So this is the picture of hydropower plant. Indonesia technical hydropower potential is estimated at around 75,000 megawatt. With untapped resource concentrate of the island of Sumatra, Java, and Sulawesi. It is estimated that there is currently about 8 gigawatt of economically viable undeveloped hydropower potential, which would provide almost 33 TWh of electricity per year. The charts from www.hydropower.org. So, hydropower is electrical energy produced through the power of moving water. Power obtained from the typically gravitational movement of water. Hydropower plants derive energy from the force of moving water and harness this energy for a useful purpose. So this is the picture about the inside from the hydropower plant. From the left side is the traditional one, and from the right side is the modern one. About the traditional, the traditional use include water mills. In modern technology, hydropower moves turbines that pass on their energy to a generator which then produce electric power. Hydropower is a type of renewable energy, and once the power plant is constructed, it produces little to no waste. Globally, hydropower contributes more electrical. Globally, hydropower contributes more electricity than any other renewable energy type. And now it's about the type of hydropower plant. There are four many types of hydropower projects. These technologies can often overlap. For example, storage projects can often involve an element of pumping to supplement the water that flows into the reservoir naturally, and run-of-river project may provide some storage capability. And this is the type of hydropower plants. The first one is offshore hydropower. The second one is the storage hydropower. The third one is pump storage hydropower. And the last one is run-of-river hydropower. Now I will explain about the offshore hydropower. The offshore hydropower is a less established but growing group of technologies that use tidal currents or the power waves to generate electricity from seawater. About the storage hydropower, it's typically a large system that uses a dam to store water in a reservoir. Electricity is produced by releasing water from the reservoir through a turbine, which acts as a generator. Storage hydropower provides base load as well as the ability to be shut down and started up at short notice according the demands of the system, or we can say peak load. It can offer enough storage capacity to operate independently of the hydrological inflow for many weeks or even months. And this is the picture of pump storage hydropower. The pump storage hydropower provides peak load supply, harnessing water which is cycled between a lower and upper reservoir by pump which is use surplus energy from the system at the time of low demand. When electricity demand is high, water is released back to the lower reservoir through the turbines produce electricity. And this is the picture of the pump storage. We can see the upper reservoir, the penstock, the powerhouse, the generator, the turbine. And this is the difference between the open loop pump storage hydropower and the closed loop pump storage hydropower. And now is run of river hydropower. This is the picture. There's a powerhouse containing turbine and generator, the penstock, the forebank tank, the channel, the intake weir, and setting basin. Run of, run of river hydropower, a facility that channels flowing water from a river through a canal or penstock to spin a turbine. Typically, run-of-river project will have little of or no storage facility. You can see it there. Run-of-river provides a continuous supply of electricity or baseload, with some flexibility of operation for daily fluctuation in demand through water flow that is regulated by the facilities. And now I will explain about the strength of the hydropower plants. There's there's the there's have the three strength of dry power plants, hydropower plants. The first is about charging up variables renewables. The second is low carbon and pollution free, and the third is low carbon. About the charging up variable renewables. Charging up variable renewables is a hydropower is an ideal complement to variable renewables wind, wind or and solar. Thanks to thanks to its flexibility and energy storage services, hydropower can meet demand when these intermittent sources are unavailable. Pump storage hydropower, operating like a green rechargeable battery, absorb energy when supplies exceeds demand. Next is low carbon and pollution free. Hydropower is among the cleanest sources of the electricity, with low greenhouse gas emission intensity compared to other energy forms. Independent research suggests that use of hydropower instead of fossil fuel for electricity generation has helped to avoid more than 100 billion tons of carbon dioxide in the past 50 years alone, exceeding exceeding even the emission averted by nuclear power. That's roughly equivalent to the total annual carbon footprint of the United States for 20 years. And now is low carbon. According to the International Renewable Energy Agency, or IRENA, IRENA, the world existing hydropower capacity will need to grow by around 60% by 2050 to reach 2050 gigawatt to help limit the rise in global temperature to well below 2 degrees Celsius. Such growth would have generated some 6,100 skilled jobs over the coming decade and would require an estimated investment of 1.7 trillion US dollar. And now is the future projections. First future projection is low cost over the long term. Low cost over the long term is hydropower provides very low cost electricity over its long lifetime, despite relatively high upfront construction costs. The source is from the International Renewable Energy that said the global weighted average cost of electricity from hydropower projects in 2080 was 0.047 per kilowatt hour US dollar, making it the lowest cost source of electricity in the many markets. Second is hydropower SDGs. Image reveal large amount of data, so use an image instead of long text. For your information, SDGs is Sustainable Development Goals, are a global action plan agreed by world leaders, including Indonesia, to end poverty, reduce inequality, and protect environment. So sustainable hydroelectricity support the achievement of the United States Agenda for Sustainable Development, as well as the Paris Agreement on Climate Change. There's 17 Sustainable Development Goals can be seen in the following figures. Yeah, there's 17 Sustainable Development Goals you can see on the screen. And among the 17 goals, hydroelectric projects can directly support the achievement of SDGs 6, 7, 8, 6, 7, 9, and 13. The goal number 6 is clean water, so it's ensuring availability and sustainable management of water for all. The goal number 7 is providing access to affordable, reliable, sustainable, and modern energy for all. Goal number 9 is upgrading infrastructure with clean environment sounds technologically. And goal number 13 is taking action to combat climate change and its impact. And there's sustainable development goals that we are raised. Next is disadvantage of hydropower plants. Um, the first is hydroelectricity power is not perfect, however, and does have some significant disadvantage. The second is hydropower is non-polluting, but does have environmental impacts. Hydropower facilities can affect land use, homes, and natural habitats in dam area. Hydroelectricity is hydrology dependent, and in some cases, hydroelectricity can disrupt wildlife habitat, and hydroelectricity can cause change in reservoir and stream water quality. Now is instrumentation and principle working. There's a instrumentation and principle working of hydropower plants. There's a guide from number 1 till number 14. In the number 1, we can see the reservoir. Reservoir is a building that is used to hold water before it's channeled through water canals. The second is okay, sorry. Second is control gate, is regulator of the entry of water into the penstock that goes to the turbine, which is controlled from the control room. The third one is trash rack, function to filter various types of dirt so that it does not enter the penstock. The fourth is intake. So the intake is the water entry cap from the dam that will be flow to the penstock pipe. The number 5 is the penstock. In the penstock is a water tunnel made of condensed pipe that produce a pressure water flow to direct the flow of water to a water turbine. The number 6 is transformer. That we know that step-up transformer is an electrical component that is used as a step-up and then transmit through long-distance transmission line. Number 7 is the powerhouse. The powerhouse is a place for turbines, generators, hydraulic equipment like governors, oil pumps, and etc. The fault settings, instrumentation, indicators, complementary equipment that support the operation of hydropower plants. Number 8 is the generator. The generator is an electricity component that is used to convert the rotation generated from the turbine rotation. And it uses the mechanical energy to electricity energy. Number 9 is the turbine. The turbine is a mechanical component that is used to convert primary energy into the mechanical energy in the form of the rotation. Number 10 is the draft tube. A draft tube is required to carry water out of the turbine runner to the tail race. Number 11 is the outflow. The outflow is the water output channel from the finished penstock used to rotate the water turbine. Number 12 is the spillway. So the spillway serves to remove excess reservoir water so that water does not overtopping, which can harm the dam. Number 13 is the fish ladder. The fish ladder serves as a means of migrating fish so that fish are able to pass through the high dam gate safely. Number 14 is the transmission line. The transmission line serves to distribute electrical energy from the hydropower plants whose voltage has been increased by step-up transformer to the consumer. So we can know the principal working of the hydropower plants is the water is in the reservoir enter the control gate, then filtered by the track rack. After that, it's entered to the penstock. So the water will turn the turbine and make the generator work. Because the generator has been connected to the turbine. Then the water exits into the draft tubs and ends up in the outflow. The generator works to produce electrical energy, which is then increased in voltage by a step-up transformer before finally going to the transmission line and ending in the consumer. So it's the picture of the generator, transformer, and the transmission line before. And about the synchronous generator is alternator is an electrical machine that converts the mechanical power from a prime mover into an AC electrical power at a particular voltage and frequency. The synchronous motor always runs at a constant speed called synchronous speed. So how it works? The working principle of synchronous motor is when the synchronous generator works on the principle of Faraday's laws of electromagnetic induction. Electromagnetic induction states that electromotive force include indulge in the armature coil if it's rotating in the uniform magnetic field. The EMF will also be generated if the field rotates and the conductor becomes stationary. Thus, the relative motion between the conductor and the field induce the EMF in the conductor. The wave shape of the induced voltage is always sinusoidal curve. So this is the picture of construction of synchronous motor. You can see on the top left, there's a stator is a stationary part and is cylindrical in shape. The rotor is a rotating part, which is also cylindrical, and the air gap is the space between the stator and the rotor. And these stator contractions, sorry, there's the frame is made of cast iron to support the anchor core. The number two is the anchor core is made of malleable iron. The third is the groove to the winding. The fourth is the anchor winding is made copper, which is placed in the slot. And these rotor contractions, the cylindrical pole type for high-speed generator consists of grooves for the field coils. The grooves are divided into polar pairs. Salient pole type for low and medium speed generator. The protruding pole consists of a polar core and polar shoe. The field winding is wrapped around the body of the pole. On the pole shoe, a damper winding is also installed. The pole windings are made of copper, while the pole body and pole shoes are made of malleable iron. And this is the step-up transformer. The step-up transformer that we know is a type of transformer with the function of converting low voltage or LV and the high current from the transformer primary side to the high voltage HV and low current value and the transformer's secondary side. The characteristic of the step-up transformer, the first one is the number of turns in the primary coil is always less than the number of turns in the secondary coil. The primary voltage is always less than the secondary voltage, and the primary current is always greater than the secondary current. And now the transmission line. The transmission line is used for the transmission of electrical power from generating substation to the various distribution units. It transmits the wave of voltage and current from one end to another. The transmission line is made up a conductor having a uniform cross-section along the line. ERYK as an insulting or dielectric medium between the conductors. For safety purpose, the distance between the line and ground is much more. The electrical tower is used for supporting the conductors of the transmission line. Towers are made up of steel for providing high strength to the conductor from transmitting high voltage over long distance. High voltage direct current is used in the transmission line. And now is the DCS, or the Distributed Control System. The DCS is a specially designed automated control system that consists of geographically distributed control elements over the plant or control area. It differs from the centralized control system, wherein a single control and central location handles the control functions. But in DCS, each process, element, or machine or group of machines is controlled by a dedicated controller. DCS consists of a large number of local control in various sections of plant control area and connected via a high-speed communication network. In DCS system control, data acquisition and control functions are carried through a number DCS control, which are microprocessor-based units distributed functionally and geographical over the plant, and are situated near area where control or data capturing functions being performed, as shown in the figure above. They're control able to communicate among themselves and also with other control like supervisory terminal, operator terminal, and historians and etc. Now is the architecture of distributed control system. As the name suggests, DCS has three main qualities. The first one is the distribution of various control functions into a relatively small set of subsystems, which are semi-autonomous and are interconnected through a high-speed communication bus. The second attribute of DCS is the automation of manufacturing process by integrating advanced control strategies. The third character is the arranging the things as a system. And this the attribute of DCS can be observed in its architecture shows in diagram. The first is the basic element comprised in a DCS include. The first is the engineering workstation. The second is operating system or HMI. The third is process control unit or local control unit. The fourth is smart devices, and the fifth is communication system. About the engineering workstation, the engineering workstation, it is the supervisory control over the entire distributed control system. It can be a PC or another, like this is in a PC or other computer that has dedicated engineering software. The second is operating station or HMI. This is used to operate, monitor, and control plant parameters. It can be a PC or any other monitoring devices that has a separate software tool on which operator can view process parameter value and accordingly to the take control actions. The third is process control unit of DCS. It is also called a local control unit, distribution controller, or process station. The fourth is communication system. For this communication system, the communication medium plays a major role in the entire distributed control system. And the fifth is smart of or intelligent devices. The intelligent field devices and field bus technology are advanced feature of DCS technology that replace traditional input-output systems. And now is a timeline is a working and operation of DCS. The first is sensor sends the process information and send it to the local input-output modules to which actuators are also connected so as to control the process parameter. The information or data from the remote modules is gathered to the process control unit via field bus. If smart field devices are used, it sends information directly transferred to the process control unit via field bus. The collected information is the further processed, analyzed, and produce the output result based on the control logic implemented in the controller. The result or control action are then carried to the actuator device via field bus. The DCS configuring, commissioning, and control logic implementation are carried at the engineering station as mentioned earlier. And the operator able to view and send control actions manually at operation system. So this is the reference from the topics. There's so many reference from the topics, and this is the sort of the pictures, and it's also sorts of the pictures. And yeah, John, thank you for your attention. Sorry for there's many cases, and see you. Wassalamualaikum warahmatullahi wabarakatuh.